Have you ever stopped to think about the numbers that define our world? These aren't just random digits you'd find in a dusty old textbook. They are the fundamental parameters of our home planet, the very rules that govern everything from the air we breathe to the ground beneath our feet. Understanding these constants is like learning the secret code of our existence. They tell a story, a grand cosmic narrative of how this particular rocky world, orbiting a rather ordinary star, became the perfect cradle for life. These numbers are the architects of our reality, shaping every moment of every day in ways we often take for granted. They are the silent guardians of our world's stability and the reason we can call this place home. Imagine for a moment a universe where these numbers were just slightly different. A little more gravity, and our bones might shatter under our own weight. A little less atmospheric pressure, and the water in our bodies would boil away into space. These constants are not just abstract concepts for scientists to ponder. They are deeply personal. They dictate the very fabric of our biology and the environment we have evolved to thrive in. They are the reason a ball falls down and not up, why we can enjoy a liquid ocean, and why the sky is a beautiful shade of blue. To explore these numbers is to embark on a journey of discovery about ourselves and our place in the cosmos. The universe is vast and filled with countless worlds, each with its own set of physical rules. But here, on this pale blue dot, the numbers have aligned in a way that allows for a breathtaking diversity of life. They are the finely tuned instruments in a cosmic orchestra, and their symphony is the story of Earth. From the pull that keeps us anchored to the surface to the blanket of air that protects us from the harshness of space, these constants work in concert. They create the conditions necessary for liquid water, a stable climate, and the complex chemistry that led to you and me. So let's explore these foundational numbers, these pillars of our world, and appreciate the delicate balance they maintain. This exploration is not just an academic exercise. It's a journey into the heart of what makes Earth, Earth. It's about connecting with the fundamental forces and dimensions that have shaped our past, define our present, and will determine our future. By understanding these constants, we gain a deeper appreciation for the fragility and resilience of our planet. We begin to see the intricate web of connections that makes life possible. These aren't just numbers on a page, they are the very essence of our home. They are the vital signs of a living, breathing planet, and it is our privilege and our responsibility to understand them. Let's start with a force you feel every single second of your life: gravity. Its official value, the standard acceleration due to gravity on Earth's surface, is about 9.8 meters per second squared. This number might sound technical, but its meaning is simple. It's the constant downward pull that keeps everything and everyone grounded. When you drop your keys, they don't float away. They fall. That's gravity at work. This relentless force is what gives objects their weight, what holds our oceans in their basins, and what keeps our precious atmosphere from escaping into the void of space. Without it, our world would simply fly apart. This gravitational constant is a direct result of Earth's mass and size. It's strong enough to hold on to us and our atmosphere, but not so strong that it crushes us. Think about astronauts on the moon, where gravity is only about 1/6 as strong. They can leap incredible distances with little effort. Here on Earth, our muscles and skeletons have evolved over millions of years to work perfectly against this specific 9.8 meters per second squared pull. Every step you take, every ball you throw, every bird that flies is a beautiful dance with this fundamental constant. It's the invisible hand that shapes the motion of everything on our planet. Next, consider the weight of the air above you. This is atmospheric pressure. At sea level, the average pressure is about 101,325 pascals, or 1 atmosphere. Imagine a column of air stretching from the top of your head all the way to the edge of space. All that air has weight, and it's pressing down on you from every direction. You don't feel it because the pressure inside your body is pushing outward with the same force, creating a perfect balance. This pressure is crucial for life. It's what keeps water in its liquid state over a wide range of temperatures, allowing for our rivers, lakes, and vast oceans to exist. If our atmospheric pressure were significantly lower, like on Mars, water would boil at a much colder temperature. The oceans would have evaporated into space long ago. On the other hand, if the pressure were much higher, like on Venus, it would be crushing. The pressure we experience on Earth is a sweet spot. It's gentle enough for us to move around freely, but strong enough to hold our world together. When you drink water through a straw, you are creating a lower pressure inside the straw, and the atmospheric pressure outside pushes the liquid up. It's a simple, everyday act powered by a planetary constant. How big is our world? The answer is another key number, Earth's radius. On average, it's about 6,371 kilometers or 3,959 miles. This isn't just a measurement, it's a defining characteristic of our planet. This size, combined with its mass, is what determines the strength of its gravity. A smaller planet would have weaker gravity, likely too weak to hold on to a significant atmosphere or liquid water. A much larger rocky planet, a so-called super-Earth, would have crushing gravity, making life as we know it impossible. Our planet's radius puts it in the Goldilocks zone of size, just right for life. This specific radius also influences our planet's geology and climate. The distance from the hot, molten core to the cool surface dictates the rate at which heat escapes. This process drives plate tectonics, the slow drift of continents that recycles the planet's crust, triggers volcanic activity, and shapes the landforms we see around us. It's a dynamic system powered by the planet's internal heat engine, and its scale is set by Earth's size. The journey from the center to the surface is a vast one, and this depth allows for the complex geological processes that make our world a geologically active and vibrant place, rather than a dead, static rock. Now let's talk about temperature. The average surface temperature of Earth is around 15 degrees Celsius, or 59 degrees Fahrenheit. This might seem like a simple weather report, but it's one of the most critical constants for life. This average temperature is what allows water to exist in all three states: solid ice at the poles, liquid water in the oceans, and gaseous vapor in the atmosphere. This delicate balance is the engine of our planet's water cycle, which distributes fresh water across the continents and drives our weather patterns. Life on Earth is fundamentally water-based, and this temperature makes it all possible. This global average is maintained by a remarkable balancing act between the energy we receive from the sun and the heat our planet radiates back into space. Our atmosphere, with its greenhouse gases, plays a vital role by trapping just the right amount of heat to keep the planet warm, like a planetary blanket. Without it, Earth's average temperature would plummet to a frigid -18 degrees Celsius. This comfortable 15 degrees Celsius average is not a given. It's the result of Earth's distance from the sun and the specific composition of its atmosphere. It's another one of those just right conditions that makes our world a haven for life. When you look at these numbers together, gravity, pressure, radius, and temperature, you begin to see not just a list of facts, but an interconnected system. They are not independent variables. They influence each other in a complex and elegant dance. The Earth's radius and mass set the stage for its gravitational pull. That gravity, in turn, is strong enough to hold on to an atmosphere. The composition and density of that atmosphere then create a specific pressure at the surface and help regulate the global average temperature. It's a beautiful symphony where each instrument plays its part in perfect harmony. This finely tuned arrangement is what makes Earth so special. It transforms a simple rocky planet into a living world. These constants create the stable, life-friendly conditions that have allowed evolution to unfold over billions of years, leading to the incredible biodiversity we see today. If you change any one of these fundamental values, the entire system could unravel. A slight nudge in the wrong direction could lead to a runaway greenhouse effect like on Venus, or a frozen desert like on Mars. The stability of these numbers over geological time has provided the consistency life needs to take hold and flourish. Our existence is a testament to this cosmic good fortune. We are creatures perfectly adapted to these specific physical laws. Our bodies are built to withstand 1 atmosphere of pressure. Our skeletons are strong enough for 9.8 meters per second squared of gravity. And our biology is optimized for a world where water is liquid. We are, in a very real sense, children of these constants. They are woven into our DNA. Recognizing this deep connection fosters a sense of wonder and humility. We are part of a grand, intricate system, a delicate balance of forces and dimensions that came together to make our home. So, the next time you feel the solid ground under your feet or take a deep breath of fresh air, remember the numbers. Remember the silent, powerful constants that make it all possible. They are the invisible architects of our world, the bedrock of our existence. They turn a random planet into our precious home, a unique sanctuary in the vastness of the cosmos. Understanding them is to appreciate the profound and beautiful improbability of our own existence. They are the physical laws of our home, and they are the reason we are here to ponder them.